In this video, we're going to look at example 1, where we write equivalent rational expressions. So the question is, when are two rational expressions equivalent? And what we want to look at is an example, using numbers without any variables, kind of some familiarity for us. So rational expressions can be simplified in a process similar to the process of simplifying rational numbers. And if we look at something like 12 over 16, we can break 12 up into 3 times 2 times 2, right? And so we have this 3 here, and I'm just going to highlight a bunch of things so we can keep track of what we're changing. And that 3 is also there. This 2 is rewritten here. This 2 is rewritten here. Then we have 2 times 2. And obviously you're not going to break this up exactly like this way. You might not write it all out in that form. But what's going to happen is that these two pieces here, right, 2 over 2 and 2 over 2 is the same as 1. And when we multiply 1, it doesn't change the value. So what winds up happening is we're left with this 3 over 2 times 2, which just becomes 3 over 4, right? Because 2 times 2 is 4, obviously. But the idea is you can take numbers back at the start, this 12 over 16, and you could just break them up into pieces, and then you're trying to reduce out fractions. You're trying to create things that are a 1 so that you can effectively cancel them out. All right, they're still there, they're still part of the problem, but when you're multiplying by 1, right, we have that identity property. So nothing's really changing there. And what we want to do is we want to take that concept and we want to apply it to some kind of rational expression. In this case, we're looking at x cubed minus 5x squared minus 24x over x cubed plus x squared minus 72x. So the first thing we want to do is we need to factor. All right, you're always going to need to factor these problems, and what I'm going to do is I'm going to take x cubed minus 5x squared minus 24x, and I'm going to write this one horizontally, but however you set it up is really fun. And I see that all of my terms up top have an x in common, so I'm going to factor out an x and be left with x squared minus 5x minus 24. And in the denominator, I also see that they all have an x in common, so I'm also going to factor that x out. And sometimes you'll be able to do that, sometimes you won't, but you always want to look to factor them. I want to continue factoring if I can, and in this case, this problem is set up so that I can. We would use factor sum charts. Again, I'm not going to go through crazy detail with the factoring because we've done that before. This is more, writing rational expressions. So effectively what we're looking for is factors of negative 24, right, that add up to negative 5. So what those factors would be is I would have, don't want to write that in orange, I would have x minus 8 and x plus 3. Because negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5. In the denominator, I'm looking to do the same thing. I need factors of negative 72 that add up to a positive 1. So in that case, I'd have x minus 8 and x plus 9. Again, if you're not sure how to do that, just go back to some of the factoring videos that we have before, and you'll be able to see what's going on there. Now, you may realize or may see already that there's going to be certain things that can be kind of canceled out. But before we do that, we do want to look at things in terms of domain, and this is where sometimes there's mistakes made. So the next thing I'm going to do is I'm going to kind of keep track of this domain here. All right, so my domain is going to be all real numbers, right? Except for x equals, and then we need to figure out what those numbers are going to be. Actually, let's not even say x equals. Let's just say all real numbers except. And what we need to look at is we need to look at our denominator. All right, we need to ask ourselves what parts of that are going to turn into 0, and that would create an undefined expression. So in terms of the domain, well, x in this piece right here cannot be 0. So all real numbers except 0. Here, we can't have x be a positive 8, because 8 minus 8 would give us 0. So it cannot be 8. And here, x plus 9, how would that become 0? That would be if it was a negative 9. So the domain is going to be all real numbers except 0, 8, and negative 9. That's just something we're going to have to go back to, but you always want to look at the domain once you're done factoring before you cancel anything out. Make sure that is the case. All right, so I'm going to rewrite this expression up top here as x over x times x minus 8 over x minus 8 times x plus 3 over x plus 9. All right, and all I did is I basically just split this up into those three groups there. So I can rewrite this again. X over x is just 1. X minus 8 over x minus 8 is again 1. And then x plus 3 and x plus 9 I can't do anything with. Right? I can't reduce that. Make sure you don't cancel or reduce out those x's. So if I was to multiply these three terms in this step here, well, 1 times 1 is 1 times x plus 3 over x plus 9 is the same expression. So what I've effectively done is I've taken this original expression here and I've factored and reduced it to an equivalent expression here. So these two terms are equivalent. All right. Sorry, these two expressions, rational expressions, are equivalent. The x cubed minus 5x squared minus 24x over x cubed plus x squared minus 72x is equivalent to this expression right here. However, this domain, although it doesn't look like it, like if I plug in a 0 here, everything is okay. But because we came from this original expression, this domain also applies to this new rational expression. And that's where sometimes students or people, or really even teachers, sometimes we forget that that domain still has to apply to the new expression because that expression came from that original x cubed term. All right, so do be careful with that. The main idea here, really what you're looking to do is factor. All right, once you factor, you'll be able to reduce, cancel, drop things out, however you want to phrase it. And then just keep in mind that the domain should be found at this step after you're done factoring, and then that domain does apply to your final expression.